This is an AI-generated instructional short of quickly build, deploy, and scale web apps and APIs with App Service Premium v4. In this session, I introduced the latest App Service Premium v4 features like sitecards, upgraded instances, and availability zones designed to enhance performance and scalability while lowering costs. You'll see how to create production-ready apps faster with demos and key insights. Let's start with our agenda. We'll explore new features in App Service that streamline app development and deployment, including sidecar extensions for Linux apps to extend functionality. I'll then demonstrate enabling Azure AI Agent Service to integrate AI effortlessly. We'll dive into availability zone updates for improved resilience, and finish with how GitHub Copilot boosts your productivity by integrating App Service best practices. Stay tuned for practical demos throughout. We now have support for Premium v4 in preview, marking the start of a journey toward improved platform features for all apps. The goal is seamless migration from Premium v3 with assured reliability and performance. Site reliability engineering agents monitor app health and respond automatically to issues like memory shortages or scale needs. Additionally, .NET and Java migration tools are available to move your on-premise apps to the cloud. General availability includes availability zones for automatic redundancy and a 99.99% SLA, which you can enable to optimize scaling and resilience. For a deep dive, check the linked blog post or demo sessions. App Service Premium v4 delivers substantial performance improvements across CPU, memory, and storage, translating into faster apps at a lower price. If you run workloads on Premium v2 or standard plans, migrating to Premium v4 could cut costs by about 24% on Windows, while offering reserved instances and saving plans for large, predictable workloads. This tier gives more scalability and advanced analytics, making it ideal for production-ready apps. Later demos show this value in action. Let's jump into a demo highlighting sidecar extensions, a powerful new way to extend Linux app functionality within App Service. Sidecars enable you to add features alongside your main app container without complex configuration, boosting what your app can do seamlessly. While Windows App Service supports site extensions, Linux apps lack this until sidecar extensions arrived. Since Linux apps run in containers, sidecars are companion containers sharing networking and namespaces with the main app. This setup allows smooth container-to-container communication on the same compute instance without extra networking hassle. Whether deploying from source or containers, sidecars let you add functions easily alongside your app. Deploying a sidecar extension is straightforward. You point to any container in your registry, add environment variables to share settings with the main app, and deploy. The sidecar runs alongside your app container, sharing networks and namespaces for seamless communication without extra complexity. This flexible architecture simplifies adding new capabilities without disrupting your app. Consider the Fashion Store Assistant chat app architecture that uses a 5.4 model as a sidecar. The .NET Blazor frontend sends queries via HTTP to a Python Fast API sidecar running the Phi model. The sidecar processes requests and streams token responses back for a smooth chat experience. This illustrates running lightweight language models as sidecars in App Service. Ready-to-use containers make sidecar deployment a single-click operation, simplifying adding AI capabilities. Integrating Azure AI Agent Service lets you embed AI agents into existing apps with minimal code changes, preserving your current architecture. The AI Agent Service supports running small language models as sidecar containers on the same compute resource, offering low-cost experimentation before scaling. Demos show how to add these extensions easily via the Azure Deployment Center, supporting multi-language communication over localhost. Sidecars also facilitate application performance monitoring integrations like Datadog or New Relic, enhancing observability with minimal setup. You should implement safeguards to validate inputs and moderate outputs. This modular container-based approach opens flexible paths for extending app functionality without rewriting code, including new features like web jobs for asynchronous background tasks. Starting small with sidecars lets you test value and scale wisely. Next, we transition to availability zones for app resilience. Here's an architecture diagram tying these components together. Internet traffic reaches App Service backed by an App Service plan linked securely with managed identity. The App Service connects to the AI Agent Service, exposing open API endpoints like /cart and /inventory, enabling modular AI integration. This design allows fast, secure addition of AI features to existing apps with minimal disruption. Despite rebranding challenges, the key is how easily this plugs into your current environment. In a demo integrating Azure AI Agent Service, I start with a fashion store app managing cart and inventory. Using GitHub Copilot, I quickly generate a chat UI where users can add items via natural language. In Azure AI Foundry, creating an AI agent is simple. Just pick a model like a smaller GPT-4 variant for demo suitability. Integration requires sharing the agent ID and connection string, and Copilot generates the code to handle messaging and response streaming. OpenAPI spec integration enables the agent to call app APIs directly without extra glue code. With deployment, environment variables lock down security, ensuring the agent accepts requests only from your app. The chat interface responds with model-powered advice, such as size recommendations, seamlessly executing actions like adding items to the cart. Availability zones enable redundancy by spreading resources across multiple data centers within an Azure region. Zone redundancy ensures your app survives a single data center outage, crucial for maintaining reliability and continuity. This foundational feature supports disaster recovery and fault tolerance in the cloud. For detailed demos on these capabilities, see the full session. In Azure App Service, availability zones distribute your app workload across 3 data centers, balancing traffic to maintain uptime. If one data center fails, your app continues on the others without downtime. Note that this protects only within one region, so multi-region deployment is needed for higher availability. All premium and isolated SKUs, including Premium v4, support zone redundancy. The platform handles instance balancing automatically, so you simply enable the feature for resilient app hosting. Availability zones are fully managed and set it and forget it. Previously, enabling them had to occur during app service plan creation with no option for later changes, requiring redeployment for adjustments. Additionally, a minimum of 3 instances in healthy zones was required for deployment. Upcoming updates will remove these constraints, improving flexibility. Recent updates introduce support for 2-zone availability, reducing the minimum instances from 3 to 2, cutting costs by roughly 33%. Apps deployed across 2 or 3 zones now enjoy a 99.99% SLA. Importantly, you can toggle zone redundancy on or off during your app's lifecycle, allowing cost savings during low demand and quick resilience ramp up as needed. This flexibility opens new possibilities for balancing resiliency and cost management. In this preview demo of availability zones, enabling zone redundancy in the Azure portal is now as simple as toggling a checkbox. There's a new property showing how many zones your plan supports, and you can switch redundancy on or off depending on your needs. You can even see the physical zone of each instance from the portal, eliminating support ticket cycles. Some apps may already run zone redundant behind the scenes without explicit settings, enhancing resilience naturally. Once the updated portal is live, check your apps to see these benefits in action. Stay tuned for more demos featuring GitHub Copilot integration soon. Now let's explore integrating app service best practices into ARM and Bicep templates using GitHub Copilot. Even without deep Azure knowledge, you can prompt Copilot to scaffold infrastructure and app configuration following Microsoft's recommended multi-region, secure architecture behind Azure Front Door. This includes blocking direct internet access, enforcing TLS, and deploying managed identities. The demo highlights how AI-assisted coding accelerates adoption of best practices while ensuring high availability and fault tolerance. Stay tuned for the detailed walkthrough in the extended session. Here, I demo a simple Python Flask app deployed using GitHub Copilot-generated AZD and Bicep templates. Copilot creates infrastructure to provision app service plans, web apps, networking, and security restrictions that only allow front door traffic. It enforces best practices like TLS versioning and disables FTPS for extra security. The app deploys in multiple regions with balanced routing, providing high availability. This shows how Copilot can make secure, production-grade deployments accessible to developers without deep Azure expertise. For the full detailed demo, watch the complete session. To get started with Azure App Service and the latest Premium v4 features, check out the official product info, generative AI capabilities, and recent build announcements. Join the Azure App Service community and follow updates on Twitter at @AzAppService. For in-depth demonstrations and practical guidance, watch the full session where you can see all these innovations in action.